Hello guys, and welcome back to another episode of chemistry, as you can see evidently on the board. And today we're going to be talking about, of course, removal of hardness. Removal of hardness of water. Okay, so I'm going to continue our study on water. Today I'm going to talk about specifically removal of hardness of water. All right, so please do not forget to like this video as you're watching now. Please, if you're a child of God, okay, all right, please just click on that like button, that hand that looks like it. Before you even continue, just click on that like button there. Subscribe to the channel, click on that red subscribe button below this video. Look at it below, you see subscribe there. That rating just is free, so just click on it. Then of course, do not forget to keep sharing these amazing videos. Okay, so likewise, this tutorial is brought to you by the O3 School JAMB app. We're going to take a question now concerning removal of hardness from the app. A 2010 question, number 13. 2010-13. It says permanent hardness of water can be removed by A, filtration, B, adding slaked lime, C, adding caustic soda, D, boiling. Okay, so these are the kind of questions you will see under removal of hardness. There are so many more that we're going to look at the end of this class, not before, because some of you know they stay. All right, so please watch the video to the end. All right, so please get the application also and start practicing your way to success. Okay, the app has all the past questions from JAMB, so you don't need to go and buy past question outside. It has a classroom that has lecture notes, okay, structured according to the JAMB syllabus. So you don't need to go and buy textbooks outside. Then likewise, we have question search feature. We even have the word mock challenge every Saturday on the app, where you compete with your mates, thousands of other JAMB bites, compete with your mates, win prizes, get used to JAMB past questions, get used to likely exam questions. Likewise, you see your score release every Saturday, so you know what they fear when they say JAMB don't release results. Or some of now, when they say JAMB don't release results, hey, your ear will leave here and enter your liver. Okay, so but you will not be scared at all because you are used to seeing your result release. Okay, you have built confidence. Okay, please jump on the app immediately. Go to Play Store, download it, and activate it for a small fee. Okay, pay the sacrifice, pass your exam at once. Okay, so now removal of hardness of water. Okay, so I'm going to talk about removal of temporal hardness of water and removal of permanent hardness of water. Okay, so there are different techniques and methods for removing temporal and for removing permanent. Okay, so of course, remember, let's talk about removal of temporal hardness first. Temporal hardness. Okay, initially we talked about temporal hardness, and we said that temporal hardness is due to, of course, it's caused by by calcium hydrogen triisocarbonate 4. That is CaHCO32 or MgHCO3 2. These are they are they are not unstable to eat. Okay, these triisocarbonates, they are unstable. We say they are unstable to heat. Okay, so and this is what causes temporal hardness. Okay, that means that a method that can be used to remove temporal hardness is by heating or boiling. Okay, and we also stated it in the last episode when we said that temporal hardness can be removed by boiling. Okay, and of course, that means when we heat any of these triisocarbonates, okay, we are going to remove the hardness can be removed, because the triisocarbonates will be broken down, all right, to be decomposed, okay, to give us calcium carbonate, which is of course the lime scale we'll talk about. All right, so now let's quickly see the reaction. So number one, first method for removing temporal hardness is by boiling. Boiling or heating. Okay, so either you boil it or you heat it. Okay, so this is one of the methods of removing temporal hardness. So the reaction now will be, of course, you're having our CaHCO32. Okay, is being heated. Okay, as it's being heated, it will decompose, of course, to give us CaCO3, then plus H2O. Okay, let me just say plus CO2, then plus H2O. Okay, this is liquid. Of course, this is a gas. All right, then of course, this is a solid. All right. So that is that for that. So it will be broken down to give us what? CaCO3, then plus CO2 plus H2O. All right. The hardness will be removed. Okay. To be completely broken down. All right. Because it can decompose on what? On heating. Because CaHCO3 is what? It's unstable to heat and can decompose on heating. Then it can be, it's a method for what? For removing heating is a method for removing temporal hardness. So now another method for what? For removing temporal hardness of water is by addition of calculated amount. Number 2, addition of calculated amount of slaked lime. Okay, so another method of what? Of removing temporal hardness is by addition of calculated amount of slaked lime. Slaked lime is called CaOH2. Slaked lime, please, these are exam questions. Slaked lime, okay, is CaOH2. Okay, CaOH2. That's calcium hydroxide. So addition of calculated amount of slaked lime, okay, is what? It's a method of removing what? Temporal hardness of water. Addition of calculated amount of what? Of slaked lime. The slaked lime that you are adding has to be calculated, because if you do not add calculated amount, you end up introducing more Ca2 plus ion into what? Into the water again. Okay, so you are trying to remove hard water, you are now introducing what? Ca2 plus, which is what? Of course, present in what? In hard water. Okay, so you have to use what? Calculated amount. It has to be what? Calculated. So addition of calculated amount of slaked lime is also what? A method of what? Removing what? Temporal hardness. Okay, this method is called Clark's method. This addition of calculated amount of slaked lime is called Clark's method. Clark's method. Okay, addition of calculated amount of slaked lime is called Clark's method. All right, so now let's see the reaction. Of course, CaCO3 also we what? We will add what? CaOH2 to it. Okay, and that will give us what? Calcium carbonate also water. All right, so let's see the reaction. So CaOH2, then plus, of course, HCO3, 2, then plus, of course, CaOH2. So it will give us what now? CaCO3, then plus 2H2O. Okay, so this is what? The reaction. Addition of calculated amount of slaked lime is a method. It's a technique for removing what? Temporal hardness of water. So having seen these methods now, I'm now going to what? Talk about what? The methods or techniques for removing permanent hardness of water. All right, so please take note of this. Remember, I said slaked lime is what? CaOH2, calcium hydroxide is slaked lime. Okay, so now let's talk about what? Permanent hardness. How can we remove what? Permanent hardness of water. How can permanent hardness be what? Be removed. Okay, we have quite a number of methods, and we're going to look at 3 of them. Okay, for removing what? Permanent hardness. All right, so number 1 is by addition of washing soda. Permanent hardness. Permanent hardness. Number 1 is what? Addition of washing soda. Okay, now take note that what? Na2CO3, okay, is what? The name of this is what? Is soda ash. Soda ash. Okay, so look at your past question. You are going to see question like this. Which of the following is what is called soda ash? You see this, you see options that has this. So please don't play with that. Why what? Na2CO3.10 H2O, okay, is what? Is washing soda. All right, so please take note of that. Okay, Na2CO3, like that is just what? Soda ash. Okay, but Na2CO3.10H2O is what? Is washing soda. All right, so please note that. So now, addition of what? Washing soda is a method for what? For removing what? Permanent hardness. I will said in the previous episode that what causes for permanent hardness is what? Is presence of what? Of soluble what? Calcium what? Sulfate. Okay, calcium sulfate, soluble calcium sulfate. All right, it's cause of what? Of permanent hardness. That is what? CaSO4. All right, and what? MgSO4. These are the causes of what? Of permanent hardness. We talked about them in the last episode. Permanent what hardness. All right. So now when we add washing soda to CaSO4 is going to remove that hardness from the water. Okay. So that is one method. So number one, addition of washing soda. So I'm going to have CaSO4 then plus Na2CO3. Okay. Dot 10H2O, which is washing soda. Okay. Then to now give us what now? CaCO3 plus Na2SO4 plus 10H2O. Okay, so do now be the product of our reaction. Okay, remember this one is what is soluble. This one is soluble calcium tetraosulfate 6, and of course this salt here that gives us what is insoluble. Okay, insoluble Na2SO4. All right, so please take note of that. So addition of washing soda is a method. It's a method of our technique for removing permanent hardness of water. So another method, of course, for also removing permanent hardness is the addition of caustic soda. Number 2, addition of caustic soda. Okay, now which one is, you say which one is caustic soda again? Please, you have to take note of all their names. So caustic soda is what? Is sodium hydroxide. Okay, it's what? NaOH. That's what we call caustic soda. So sodium hydroxide is what? Is caustic soda. Sodium hydroxide is caustic soda. Take note of that. It's an exam question. If you say you want to prove, go to a question search feature on your OTG JAMB and search for caustic soda. You will see that you see a question on on that. All right. So please, addition of of caustic soda, NaOH, is a method for removing permanent hardness. All right. So what happens is of course, I'm going to have a CaSO4 as usual. Then of course plus NaOH. This will now give us what now? CaOH2, then plus CaOH2 plus Na2SO4. Na2SO4. Okay, and again, this one is is soluble. This is soluble calcium tetraosulfate 6. Why this one is an insoluble salt. Insoluble sodium tetraosulfate 6. That is that is given out. Okay, so now those are 2 methods now that we have seen that is used for of course for removing permanent hardness. The third method for removing permanent hardness of water is the use of ion exchange resin. Use of ion exchange resin. Okay, this is the third method for removing permanent hardness. Okay, so now in this method, which is the ion exchange resin, I'm showing you currently a picture of an ion exchange resin. Okay, so an ion exchange resin itself contains ions. All right, so hard water is being put into the into the resin. As hard water is is put into the into the ion exchange resin. All right, the exchange, the ions are being exchanged, or displacement happens. Okay, and the product is usually a soft water, not a water that is hard again. All right, so that is that's what an ion exchange resin does. Okay, exchange of ions, as you can see, ion exchange. Okay, so exchange of ions, displacement of ions. Okay, now sodium. Okay, that is number 3 now. Ion exchange resin. Okay, so in this case, what happens is that sodium zeolite. Sodium zeolite. Please take note of that. Sodium zeolite is also called permutate. Permutate. Okay, please take note of that. Sodium zeolite is also called permutate. Permutate, which is of course, which is sodium aluminium triososilicate 4. Okay, all right. Sodium aluminium triososilicate 4. So that's sodium zeolite or permutate. Okay, so sodium zeolite permutate, which is sodium aluminium triosocarbonate 4. Okay, is an ion exchange resin. Okay, it is an ion. It is an ion exchange resin. Okay, the formula for this ion exchange resin is this sodium aluminium triososilicate 4 is simply the formula. The formula is simply Na2Y. Okay, this is what the simple formula, Na2Y. Okay, Na2Y. That is a simple formula for what? For the ion what exchange what resin. All right. So what happens is that what we pour what water that is hard into what? Into the resin. Okay, once pour water into containing what hardness. That's what we pour what hard water into the resin. What happens is that the sodium ions from this resin, they leave the resin and then they enter into the water. So once they enter into the water, what happens is that that sodium ion will displace the calcium ions that are present in the hard water. Okay, when it displaces the ion, the calcium ion will now stick to the resin, to bond itself to the resin. Okay, let me go over that again. So in the ion exchange resin, all right, we have this ion, we have sodium ion inside, okay, in the resin. All right, so when we pour hard water into the resin, what happens is that this sodium ion, okay, present in the resin, we leave the resin and and enter into the water. Okay, once it enters into the water, what happens is that it displaces the calcium ions in the hard water. You know, hard water contains calcium or magnesium ions. Okay, so it will displace either the calcium ion or magnesium ion. Okay, so it will displace the calcium or the magnesium ion in the water. Once it displaces the calcium or the magnesium ion in the water, the calcium ion that has been displaced will now stick itself to the resin. Okay, and because it has stick itself to the resin, if you want to use the resin again, okay, that is called regeneration. If you want to regenerate the resin again, what you do is you add a concentrated solution of sodium chloride, okay, to regenerate the resin. Okay, so I'm going to show you the reactions, okay, as it happens. Okay, so what happens here, the formula is simply Na2Y. So now the sodium ion, okay, when hard water is poured into the resin, the sodium ion, the Na plus ion, sodium ion, okay, leaves the resin. It leaves the resin and enters into the water. Okay, so as it enters into the water, it then displaces the sodium ion now displaces the Ca2 plus ion in the water. Okay, as it displaces the Ca2 plus ion in the water, then of course it will leave a precipitate of insoluble Ca2 plus. Okay, it will leave a precipitate of insoluble Ca2 plus. Okay, so as I displace Ca2 plus from the solution, okay, what happened is that the Ca2 plus will now bond itself. The Ca2 plus, that calcium ion or the magnesium ion bonds itself to the resin. Okay, though this is what happens in the ion exchange resin. So after the process, if you want to regenerate the resin, what I say is that take note, you add a concentrated solution of sodium chloride, a concentrated solution of NaCl, that is sodium chloride. Once you add it, when we pour it into the resin, it will regenerate the resin and we'll have our resin back. Okay, so we say the formula for the simple formula for resin is is Na2Y. So now let's see the reaction. So we are going to have CaSO4 then plus Na2Y. Okay, so this is the formula for the resin. Okay, so now what it will give us is CaY then plus plus Na2SO4. Na2SO4. Okay, so this is the reaction. Okay, so this is the water containing hardness being poured into the resin. Okay, as it is poured into the resin, all right, the sodium ion will displace this calcium ion. All right, as it displaces it, of course, I'm now going to have CaY plus Na2SO4. Now this Ca now having the Y is now having the formula of the resin. Okay, so because the calcium ions, like I explained earlier, has bonded itself to the resin. So if you want to now remove Ca, if you want to regenerate the resin, what you do is you add a concentrated solution of NaCl. So if you do that now, I'm going to have CaY now. This is resin now having bonded, Ca2 plus bonded to itself, then plus NaCl. Okay, so if you do that, I'm going to have plus 2 NaCl. I'm going to have now Na2Y, then plus plus Na2Y, then plus CaCl2 plus CaCl2. All right, this salt This salt is soluble. Salt is soluble, that one salt is insoluble. All right. So that is what happens in the ion exchange resin. Sodium zeolite is permitted, which is of course sodium aluminum triosilicate 4. Then what? It is what? The simple formula is what? Na2Y. All right. So when we pour hard water into it, the sodium ion from the resin, we leave the resin and what? Bond. Okay. And what? I enter into the water rather. So displacing what? Ca2 plus, which causes hardness in the water, and then of course the Ca2 plus will bond to the resin. Then we use concentrated NaCl to what? To regenerate the resin. Simple as ABC. Okay, so this is what? Method for what? For removing, these are the methods for removing permanent hardness of water. All right. In other words, okay, or as a summary, what it means that softening hard water involves a process or techniques of what? Of converting what? Soluble Ca or what? Mg what? Salts. Okay, soluble into what? Insoluble what? Ca or Mg salts. Okay, calcium or magnesium salts. All right, it's as simple as ABC. So these are the methods that we use in what? In the removal of hardness, both temporal and what? And permanent. Take note of what? Of the methods, okay, for temporal and for what? And for permanent, so that whenever you encounter them anywhere, it will be easy for you. So let's go to the O3 Schools JAMB app and answer questions pertaining to what? This topic. 2010-13 says permanent hardness of water can be removed. Permanent can be removed by A, they say filtration, B, adding slaked lime, okay, C, they say adding caustic soda, D, they say boiling. Okay, filtration is wrong. Adding slaked lime for removing what? Temporal hardness. So by adding caustic soda, okay, that's what? NaOH, all right, is what? A method for removing permanent hardness of water. So you must take note. So let's look at 2012-14. 2012-14, they say the chemicals used to soften hard water involves the addition of the chemicals used to soften hard water involves what? The addition of what? A, they say insoluble sodium compounds which form soluble solutions of calcium and magnesium ions. Okay, which is wrong. Okay, we'll talk about what? Soluble what? Calcium or magnesium what? Salts. Okay, which what now gives what now? Insoluble what? Calcium or magnesium what? Salts. Okay, so it's as simple as ABC. So we said that what is from soluble Ca or Mg ions to what? Insoluble Ca or Mg ions. All right, it's as simple as ABC. So B, they say soluble sodium compounds which form soluble solutions of calcium and magnesium. Soluble, wrong. Okay, it's soluble to insoluble. C, they say soluble sodium compounds which form insoluble precipitate of calcium and magnesium ions, which is well, very, very well correct. Okay, D, they say insoluble and insoluble, wrong. Okay, it's from soluble to what? To insoluble. All right, so now let's go to 2023 number 33. 2023 number 33 says, which of the following methods can be used to remove temporary hardness from water? Temporary. Okay, that is either by heating or boiling. Okay, and by addition of what? Of slaked lime. Okay, so A, they say boiling, B, filtration, C, chlorination, D, distillation. A, boiling is the correct answer. Don't need to what? Beat around the bush. 2017-36. Which of the following is the function of calcium hydroxide? Calcium hydroxide in the treatment of what? Municipal water supply. Calcium hydroxide in the treatment of municipal water supply. Of course, that is what is for removing what? Hard water. A, they say killing bacteria in the water. B, they say removing the hardness of water. C, they say coagulating solid particles. D, they say what? Controlling the pH of water. When we talk about what? Addition of what? Calculated amount of what? Of slaked lime, okay, which is calcium hydroxide. All right, that's a method for removing what? Hardness from what? Remove temporal hardness of water. So correct answer there will be what? B, removing the water hardness. So C, 1999 number 11, they say the method that can be used to convert hard water to soft water. The method that can be used to convert hard water to soft water is A, they say chlorination, B, passage over activated charcoal, C, the use of an ion exchange resin, D, aeration. Okay, correct answer is what? Ion exchange resin. So still on the board. All right, so these are some of the questions we sourced from the app. There are thousands of other questions on the O3 School JAMB app. Jump on the application today and what? Activate your app to get full benefits rather. All right. Like the videos, comment, subscribe. All right, and I'll see you in the next episode. Thank you for watching.